Let's look at some more examples. Doing the process more than once and having to solve an equation. What does that mean? Well, let's take a look at this one. Obviously a product, e to the 3x times sine of x, and we cannot make it not a product. Let's start by writing down what our integration by parts formula looks like. The integral of u dv equals uv minus the integral of v du. Now, liate to help us determine what we want for our u. Do I see logs? No. Inverse trig? No. Algebraic? No. Trig? Yes. I see trig. Here's the trig. So the trig will be my u. So u is sine x. That means everything else will be dv. So I make my box with the 4 quadrants, u, v, du, dv. Let's put our u, sine of x. Everything else is dv, e to the 3x dx. To go from u to du, derivative. To go from dv to v, antiderivative, e to the 3x over 3. Now we make our 7. uv, v du. Let's write that in. uv, sine of x times e to the 3x over 3 minus integral v du. E to the 3x over 3. Oops, I did it again. Don't forget the dx. The d's have d's in them. Cosine of x dx. Now, let's look at what we have here. Again, a product, e to the 3x over 3 times cosine x, and again, I cannot make it not a product. So we're going to do u substitution again. Let's make another box and section off the quadrants, u, v, du, dv. Again, we have trig, so again, that'll be my u. Cosine of x, everything else will be my dv. E to the 3x over 3 dx. Let's take our derivative, negative sine x, dx, and our antiderivative, e to the 3x over 9. And now let's make our 7, uv, v du. uv. So remember, that's just for this part right here for this box. So for this part right here, uv cosine x times e to the 3x over 9 minus integral v du. E to the 3x over 9 times negative sine x dx. Let's write everything else that was around it. The negative in the front, the sine of x times e to the 3x over 3 before that. Let's look at the integral that we still have to solve, and I notice again a product, e to the 3x and negative sine of x. It seems like we keep getting exponential times trig, exponential times trig. It's just a cycle. It's not going away. However, look at what I notice as I examine this exponential function and this trig function. It's now the same integrand that I started with, except for a few constant multiples, but they can be pulled out. Let's do some simplifying, and you'll start to see something that I'm noticing too. So sine of x, I can take out the 1/3. In fact, I might put the e to the 3x in front also. So I'm going to call this, instead of sine x first, 1/3 e to the 3x times sine x minus, rearrange this as well, 1/9 e to the 3x cosine x minus a negative integral makes plus, but I have a negative here, so plus a negative, take out the ninth, 1/9, so negative 1/9, integral of e to the 3x times sine x dx. Now remember, all of this is equal to what I started with. I started with the integral e to the 3x times sine x dx. Ultimately, I want to know what this equals. Well, notice how I have the same term, like terms on both sides. I can combine like terms and solve this equation. If I have negative 1/9 of these, I can add 1/9 of these integrals to both sides. I'm adding 1/9 of the integrals e to the 3x sine of x dx to both sides. Gets rid of it from this side. Let's write what's left over. 1/3 e to the 3x sine x minus 1/9 e to the 3x cosine x equals 1 plus 1/9, 9/9, plus 1/9 is 10/9 integrals e to the 3x sine x dx. Ultimately, I want the integral by itself, so I'm going to get rid of the 10/9. Multiply by the reciprocal 9/10 on both sides. And let's complete it. I'm going to put this in the front. Integral of e to the 3x sine x dx will equal, distribute the 9/10. 9/10 times 1/3. 3 goes into 9 3 times, so that's 3/10 e to the 3x sine x minus, here the 9's cancel out, 1/10 e to the 3x cosine x, and when we're done integrating, plus c. How awesome was that? You said it. Let's look at something else exciting. Go ahead and try number 8 when you have a minute. In the meantime, I'm going to show you the tabular method for integration by parts. Now, this is a quick way to use integration by parts when you know that one term will disappear. Usually that's when you have an algebraic function, meaning, let's say I start with something like x cubed and I take its derivative, I get 3x squared. If I keep taking its derivative, 6x, 6, eventually it disappears. It goes to 0. That's what I'm talking about. So usually this is when you have an algebraic function as one of the pieces of one of the factors of the product. That's what we have here. We have an algebraic function and a trig function. So because we have this that'll disappear, we know that we can use the tabular method. So that's what I'm going to show you here, the tabular method. This is a quick way to do the integration by parts, but it only works when one term will disappear. Now, I still go according to Lyate, but because this only works when one term will disappear, which is when we have an algebraic function, the algebraic function is going to be the u. So x cubed is the algebraic function, that's my u. Everything else is my dv. The tabular method is called that because we make a table. On one side of the table, we write u. The other side, we write dv. On the u side, we put what we picked for u, x cubed. On the dv side, we put what we picked for dv, cosine of x dx. On the u side, we take derivatives, just like we were doing before. On the dv side, we take anti-derivatives, just like we were doing before. But we do it quicker. We keep taking the derivative until the term disappears. So x cubed, derivative is 3x squared, derivative 6x, derivative 6, derivative 0. Term disappeared, we stop. On the dv side, we take antiderivatives until we get to the last line. The last line is where we have a 0. Antiderivative of cosine is sine x. Antiderivative of sine x is negative cosine x. Keep taking antiderivatives, antiderivatives. I got to the 0 line, so I stop. Now remember the formula for integration by parts. uv minus integral v du. Because of the minus, every time we do this integral and we do the integration by parts, it makes the signs opposite. Opposite signs. But the beginning is positive. Positive at the beginning. So we start with positive at the beginning and then alternating. Negative, positive, negative, and that's it. If this was dv, that means this is v. So this is what u is, this is what v is. So the formula goes uv, 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 where normally we'd have to do the integration by parts multiple times. In fact, 1, 2, 3, 4 times. Instead, we just use the table. So here's our answer. U times v, x cubed sine x, minus u times v, 3x squared negative cosine x, plus u times v, 6x negative sine x, minus u times v, 6 cosine x. We're done integrating, so we write plus c. Now we can clean this up a bit, so let's go ahead and do it. X cubed sine x plus 3x squared cosine x minus 6x sine x minus 6 cosine x plus c. And in one fell swoop, done! I'm super excited too. Why don't you try number 10 on your own? Don't worry, it'll only take you about a minute. See you in class!